All right, welcome everybody. Another fantastic, one of my favorite repeat guests here. It's like the greatest thing ever. I think Rob, you're your most appearances. So I got to give you a special award for that one. I'll bring one to KubeCon. And but yeah, thanks for joining today. I'm excited.
oldest guest too, I think, but not age-wise, just in longevity.
Yeah, that's right. So we've been talking a lot. We've been talking for a decade. We've been to a lot of KubeCons. We've been at, they were once called the OpenStack Summits, then they became Open Infra. We've been at VMworlds. We've been at a lot of events.
We have.
And we've gone on a lot of runs to extend these conversations. And every time we get together, we end up kind of always coming to we keep having the same problem discussion. And we're seeing this, like I see it in the market, coming from my own ops background. And of course, you are obviously heads down in really kind of high scale implementations. So we're going to talk about why do we still have to talk about the infrastructure automation problem in 2025. We've been doing this for a while. But before we jump in, I should say, Rob, you want to do for folks that are brand new to you, give a quick intro and a little snippet of what Rackn solves.
I would be happy to do that. So as you're implying, I'm Rackn, and you're right. For the last 15 years, really for my whole career, so I go back in data center automation 25 years, I have been enmeshed in the true guts of running and managing data centers at the bare metal infrastructure layer. So that's meant doing a lot of virtualization. It's meant doing a lot of Kubernetes. I have been, in one way or another, helping shape and build scale data centers for quite a long time. Personally, and for the last, we're over a decade old now, my company Rackn has been working to try to create standard repeatable processes and automation for the bare metal layer of data centers using our product called Digital Rebar, where we literally automate everything that's necessary to run a data center from the ground up. So that's, it starts with PXE booting, DNS, DHCP, out-of-band management for servers, Bootstrap, agent, day two operations, right? We literally have had to build out all of the necessary components to run large-scale infrastructure in a very repeatable way. So the thing that's notable about Rackn, and I think will be helpful for the conversation, is that it's not just about building the tooling to do this. That is important. That's what Digital Rebar does. But Digital Rebar was built because we wanted to help make the automation and the processes and the knowledge reusable and repeatable. Right. Our origin story for Rackn goes back to when my co-founder and I, Greg Althouse, were at Dell, and we were trying to ship clouds from the factory. And what we kept finding was that each data center was different, and the processes were different. And even though we shipped the same gear everywhere and the same topologies, and we're trying to install the same software, the differences kept making it so that we ended up with bespoke custom installs time again. What you've been talking about. And our mission has been to try and create some repeatable usability, turn that into software, right? What infrastructure as code sort of is supposed to mean. That's the vision of what we're trying to do, so that people don't have to become experts in bare metal and firmware and configuration management and OS installations. That knowledge is really esoteric. It's not something that adds a lot of business value, frankly, to anybody.
Well, the interesting thing too is we've seen the industry catch up in a lot of ways to the capabilities. I mean, just even the work that we've seen in innovation around growing Redfish, IPMI, and like standardizing on protocols, standardizing on everybody, at least having some really safe and highly controllable out-of-band management. It started to solve this problem for us, like as builders, to can I now take and manage this infrastructure? And that was always a huge gap. But then on top of that, the pattern for builds, we're humans, so we're stupid. Well, we just, by default, we say, well, let's just try the build, make sure it works, and then we'll kind of come back and recheck it. We'll do it again just for one
Yeah.
for a test and one for the film. But then when we do the first one and the test works, you're like, done. Don't uninstall it. Like, it's working. Just roll.
Oh, yeah, the absolute worst pattern ever. Yes. Yeah, I
Exactly.
got it working. I don't know exactly how because it's some magic incantation that I can't repeat. And so you move away. Yeah, that's what leads to global failures of infrastructure, frankly, when we get into that type of scenario. I do want to go back because there's an interesting piece about, you made a comment about Redfish and replacing IPMI. And there is this idea that if we have a standard protocol, that we're going to solve the management problem. And the funny thing is, there's a lot of necessary heterogeneity in data centers. I think this is what the mistake people make. They come in and they're like, I'm going to take this sea of all these different protocols and I'm going to create one protocol to unify them. And now we're just going to have one way to do things, which is really, you have all the old ways plus the new way.
That's right.
It's a reality. Redfish is not consistent or repeatable across vendors. And people are like, but it's supposed to be. And it's like, well, it's worth remembering that heterogeneity in infrastructure exists for a reason. It adds value for it to not all be consistent, right? Some of that is innovation. New things come up and changes. Some of it is you need to have different ways to do different things in infrastructure. It's just normal. It would be like trying to tell somebody that every plug had to be the same or every USB port had to be the same. Even if, as we want standards, there's still reason for variation.
Yeah.
And I think that's one of the things that doing what we do, you have to embrace the fact that it's a heterogeneous environment, and it should be a heterogeneous environment. As soon as you get into only one way to do things, you end up with where we are with the VMware debacle, where everybody's panicking because the one vendor, the one way suddenly became less attractive. So heterogeneity is valuable.
As a Frenchman by origin, vive la différence. This is what we should celebrate. Like, there's a reason why we've opened all these capabilities. We don't want to bring stuff to the lowest common denominator for performance and features. What we want to do is bring it around to the lowest common denominator for artifacts. Like, at least, like, we have elements and artifacts, and like those, the way that we engage with those, common APIs, common methods, but underneath the covers, that could look fundamentally different from one provider to another. And we should embrace those. We used to see the struggle of like the generic storage driver in Kubernetes. You're like, oh, this is great. I've got 3 actions I can take on storage. You're like, meanwhile, I paid $1 million for the storage rack. So of course we have custom drivers, we've got custom plugins, and then you can unlock data deduplication, understanding of, failovers. But that is it's really tough to manage like an ecosystem standardizing on something, but also opening up to future growth. And I feel like Kubernetes now, especially because this is 10 years of KubeCon, right? I think this is actually the 10th edition. Man, we are it's a decade year this year. And actually 10 years since my first Kubernetes contribution, ironically enough, where I corrected the docs because they spelled Kubernetes wrong. But hey, everything counts.
Commit.
But the goal of, 10 years in, Kubernetes itself is no longer the star of KubeCon. The things that we do with Kubernetes are now the star of KubeCon. And we think infrastructure is now boring, and it should be. Same as storage. We've been talking forever about, hey, storage is boring. It's the most unboring thing I've ever worked with in a data center, especially now with new workloads. So maybe, Rob, let's talk about why now, 10 years in, why is the conversation still there, but why is it actually much more valid now?
It's fascinating to me because, from the day one in Kubernetes work, I've been trying to do bare metal Kubernetes. And, it hasn't been very interesting from that perspective, in part because virtualization in cloud was so accessible.
Right.
And so a lot of the times where people, and we had this conversation, 10 years ago now, a number of times where we would show up and build a Kubernetes cluster, and people would be like, wow, that's really cool. But you would say, well, first you have to build this, infrastructure manager, and then it'll do all this Kubernetes stuff for you. And they're like, well, I don't need to do that. I just use kops and I hit go and it installs to the cloud and everything's done. And so there wasn't a lot of appetite for building an architecture infrastructure around Kubernetes to do infrastructure work when the cloud APIs or the virtualization APIs were so prevalent. And we've really gotten used to the idea that I can always get to cloud or I can always get to VMware, because VMware is the standard for enterprise, and just do that work using those APIs. And so I don't think that the interest isn't there. I think that the usage pattern for Kubernetes and the availability of virtualization have meant that you didn't have to do a lot of the work. And I would still tell people I'm very adamant about this. If you're doing traditional app dev with Kubernetes, and you build clusters the way people are doing, you have dynamic, cluster changeovers and things are rotating and you're resizing your clusters dynamically, those are places that should run in VMs. There is no benefit to putting bare metal in that use case. It's not providing performance benefits, scale benefits, right? You can do everything you need with VMs, and you should happily do that. The places where we see people suddenly saying, wait a second, I need to understand bare metal and Kubernetes, are the use cases that are different than the app dev dynamic use cases. It's a virtualization use case or an AI workload. In those cases, those aren't actually dynamic use cases from a host perspective.
Right.
Above that they are, but just managing the infrastructure, you're really buying the infrastructure that you want to virtualize or run AI workloads on, and then you're maximizing that as much as you can. It's a different way to use Kubernetes. It's a different use case for Kubernetes.
Now with Kubernetes, it was always the talk of Kubernetes on VMs, for the longest time, because they said it was a simple deployment pattern. It meant that you could easily plug in. You didn't need extra hosts and clusters. You could just deploy it side by side. And I saw a lot of implementations, even with OpenShift being effectively kind of a large enterprise, standard, but they're the most popular, I think, single enterprise, type of distro. Goodness gracious, my brain is at the end of the day here. So an enterprise distro with that larger support model wrapped around it. But most of the implementations were actually sitting on top of VMware for a variety of reasons. And mostly it was like hardware accessibility and control. I can't build my Kubernetes and have it live differently than my VMware. It was a weird pattern.
Well, it's not just that it's a weird pattern. I agree with you. OpenShift is the dominant in our customers, which are large Fortune 1000 customers. They do need a distro when they buy. The dominant distro is OpenShift, and OpenShift offers a lot of one. It's opinionated, which is helpful for enterprises, and two, it actually offers a lot of ancillary services in the ecosystem. So they've curated the ecosystem, both of which are very valuable. If you look at a Kubernetes landscape and you try to figure out, team one is going to pick X projects and team two is going to pick different projects. And that's just a mess for an enterprise perspective. But it's actually not the tech. For enterprise, in a lot of cases, it's actually the politics and the siloing and the way they break work. And so having an app dev team that's able to just do app dev work and manage Kubernetes and do their own thing, separating that from the infrastructure below that so that it's a different team's problem. And that means getting access to a VMware infrastructure and just consuming VMware. That isn't a technical benefit. It's a technical benefit in some ways, but it really is a political benefit, for the way companies have organized how they split the work up. And even this is one of the things that we say when we look at Kubernetes and OpenShift, for these enterprises, a strategic common platform. A lot of them are making the mistake of thinking that their Kubernetes pros are also infrastructure pros or AI infrastructure pros or virtualization pros. And that's not the case. These teams are the people who've been running Kubernetes and OpenShift in enterprise, their specialty is the platform team up. They don't know the infrastructure side. And I think when I've watched companies let the virtualization decisions come down through the Kubernetes team, and sort of, they try and create a little barrier. Oh, I'll do all this work now. It's going to be Kubernetes. They're missing the idea that there's actually a lot of skills and teams that they should be bringing into the platforms, or actually really acknowledging that that's a different use case for the same platform. It's not app dev Kubernetes. It's virtualization Kubernetes or AI Kubernetes. And they're different skill sets and different needs, but a common platform. Very beneficial to have a common platform, but it doesn't mean it's going to be run by the same team that's currently running your app dev Kubernetes.
Well, I think this is also one of the biggest problems we have in any kind of B2B infrastructure stories. People always say, like, your target ICP, your ideal customer profile, is a developer. And I always pat people on the back and say, good, I'll see you in 2 years when you realize that that's actually not the case. Good luck and may your God go with you. And I'll see you on the other side of a bad pipeline, because it's a really tough thing to actually sell to developers. Developers are the customers of our customers, right? So our customer is ops, SRE, DevOps, even DevOps, I think, is, people just like threw that in there to keep their LinkedIn, relevant. But what they're actually doing is still much more ops focused, or much more still in that dev world. And they just want to I want to set up labs fast. I want to be able to spin up infrastructure as needed. That was the demand for DevOps. But functionally, it's a very infrastructure bottom-up type of thing, like you said. And then you're crossing application people. They still need network. They need firewall. They need security. They need, all of this other stuff. So now you've got all these other teams that they have to communicate with, and I barely want to hang around with the network folks, let alone make a developer do it. It's there's so many different languages.
And this is one of the reasons why the infrastructure team in VMware is so powerful, and it's been so hard to replace VMware, because if you are building that platform, VMware has really strong networking virtualization. And so you don't have to involve a lot of teams in order to give somebody a dedicated, Kubernetes pod or an infrastructure, right? They can build 10 clusters and have their own private networking, and everything's very smooth from that perspective. And so, there has been very little reason to mix those teams. And even now, if we're big proponents of this idea of KubeVirt or OpenShift virtualization, if you want the branded version, but Kubernetes and KubeVirt as the virtualization layer to replace VMware. We think it's incredibly productive. It's very powerful. It's a very flexible way to provision that infrastructure. But you need to think of it as a virtualization layer, right? Not as containers plus VMs and mixed together in one happy gumbo. It still is a stratified layer, right? The networking and topologies and the governance and the storage, like you were saying, all of those things to drive a virtualization layer have to be done in a certain way with certain protections and isolation. And that's all possible, but you don't commingle that with, this cluster is running my SAP HANA implementation, and I'm okay if it's mixed in with other stuff. That's, there's a reason to separate those capabilities out. And that's one of the things that makes this hard, why bare metal doesn't show up from that perspective, because, the app dev teams have no patience to worry about real networking topologies and managing a VPN and trying to create storage segmentation and back up the images. All that stuff is real work, has to be done. And it's stuff that's new from a Kubernetes perspective.
Well, the other thing that we're seeing, I think, is one of the most important things for me is thinking as an enterprise consumer and enterprise architect, is I need to satisfy a ton of other, security and compliance frameworks. And everybody thinks that begins at the app up or even the virtualization up, maybe the OS up. Like, there's certain things, but it's like the whole idea of broad ubiquitous access to hardware through APIs is now those are new layers that require compliance. The processes wrapped around them require consistency, guarantees, law, like all of the stuff that we never thought that we would have to care about. Does my 8-point checklist for deploying a VMware host need to go to Deloitte for validation? It's like, no, but what you're doing, these are compliance bound industries and workloads.
It's, and this is one of the reasons why we have these segmentations and boundaries, right? I was talking to our CTO Greg Althouse, and we keep running into using Digital Rebar to install platforms, right? Kubernetes, VMware, Hyper-V, Windows types of systems, and it's always tempting to have a very sort of tight integration and mix a whole bunch of pieces together. But what we found over time is that having a firmer boundary between the two allows for that separation, right? One of the things that we see that people are trying to do with the community-based bare metal pieces, those make an assumption that you're an app dev team doing the work, and they will try to do out-of-band management or try to do, ISO attached storage, which is problematic, tricky, and hard to maintain at scale, right? It works great in the lab, but
that's right.
The
worked on DevStack.
that you need to do to drive that does not work easily, and so you end up with this incredibly commingled design and architecture. And people, especially the Kubernetes community, I understand, wants Kubernetes to be the heart of everything, and Kubernetes on Kubernetes on Kubernetes, just like we had the same thing that happened to OpenStack. But like you're describing, the segmentation and layers of controls are actually helpful. They simplify bootstrapping. They simplify security concerns. They simplify the responsibility for who does what. And so part of what we try to help people understand is, there's a level of baseline automation. If you get that really, really tight, like what we work to do, then building things on top of it become very fast. When you start to try and intermix those things, it's slow down, or you create a lot of confusion, or you create patterns that aren't repeatable. And going back to my intro, it's, we are about repeatable patterns. If we're struggling to find a repeatable pattern, that's cause to go back to a new sheet of paper.
The workloads also really fundamentally opened up new application operation patterns. Obviously, everybody's dripping, with AI off of everything. Everything is now with 100% more AI. And even looking at the schedule, there's 102 mentions of Kubernetes in the schedule for KubeCon, and there's 61 mentions of AI. So, it's literally KubeCon, and there's half as much of those conversations have AI in the title.
This part.
This is where we are now. The workload pattern is not just about doing AI on existing infrastructure. You have to, if you do that, that's really just a faster horse. A faster, very tired horse.
This is the funny thing about the AI infrastructure. Kubernetes is being used quite a bit in AI infrastructure. For training, for inference, right? It is very clear. This is one of the big breaks from traditional HPC, high performance computing, that high performance computing typically was batch oriented, and they had Slurm and other technologies for batch processing. The AI workloads are fundamentally different in that they have a lot more east-west traffic. They're trying to build large memory models. They have to share a lot of information between hosts in order to capture that type of larger environment. They have much more difficult and challenging network topologies to build for these systems, for training, definitely, but even for inference. And then even for training, storage, which people don't think about, as you're training a model, you have to checkpoint the model. And so it's incredibly important to be able to very efficiently store huge amounts of information, because every second you spend doing a checkpoint is time you're not spending doing training. And so all of these concerns really intersect in very challenging and interesting ways from a hardware design perspective. And what people forget about when they look at these AI workloads, and I think this is also true for virtualization. So bear with me. I'll try and I'm going to explain it for AI, but it is the same for virtualization. Each node in an AI infrastructure is in a specific place doing a specific thing, and it has a relationship with its neighbors. Right. So it's not, you don't have a pool of AI workloads that you use. where they're generic unclassified machines that you can just pull in. That's the current Kubernetes pattern for app dev. But for AI workloads and for virtualization workloads, each machine has one, they're really expensive, so you want to make them work. You don't want idle machines waiting for a possible need. You don't take a $40 million machine and put it on standby for when it subs into the pool. But each one of those machines has a specific network topology that fits in and works with its peers. And so you actually have to treat it as a much more static member of the cluster. Same is going to be true for a virtualization cluster. And that difference fundamentally changes the dynamics of how you think about Kubernetes and clusters than if you were doing an app dev where the purpose is to have these very generic high turn rate machines that you can expand or contract. In an AI cluster, you don't contract an AI cluster. You use as much of that capability as you possibly can, as quickly as you possibly can. And you can't expand it because you don't have spare infrastructure. So you're going to set up, run, and maintain that cluster to its maximum extent as quickly as you possibly can. And when you have to do maintenance on that cluster or any of the nodes, you're going to do that as fast as you possibly can and reset the system back to its bounds and run it. Now, Kubernetes is amazing as a scheduler and a manager for the workloads on top. And we're seeing some really nice innovations. I expect to see a lot of this at KubeCon. There was a keynote from CoreWeave at the last KubeCon talking about the work they're doing. And I know NVIDIA and AMD both are building CRDs and operators to help manage AI workloads on top of Kubernetes better. What you don't hear talked about as much is this idea that I've built that cluster. That cluster has an exact configuration and a boundary, and every node plays a part. And I have to patch and update and keep that whole system running as much as I possibly can, as fast as I possibly can. It's actually, now we're back to why it's such a different use case to do physical infrastructure. Those places where you want Kubernetes on bare metal are different and distinct use cases for Kubernetes than what we've been doing for the last 10 years.
When you mentioned too that, as we look now, what often ends up happening is a new pattern develops because of an impending change in how we do something. In this case, so AI workloads have a very distinct set of requirements, a very distinct set of behaviors that are fundamentally different from traditional long-running, virtualization, and even just like short-running, Kubernetes classic container infrastructure. But we used to say like, hey, let's co-locate all these things. Like you said, we don't do that. We're not looking about sharing and maximizing the sharing capability of this. We're looking at this thing should be like the Play-Doh machine. You just shove the thing in, you press as hard as you can, and out comes this fantastic, perfect thing. And then you get the next one ready, and then you say, okay, now time to clean it out. Let's get ready for the next, because these are very batch-oriented, very asynchronous in the way that they're delivered. It's just the operations pattern. But now, what we learn from this, then you start thinking, you go, hey, wait a second. Why aren't we doing the other infrastructure this way? And I think now this is the chance where the why now for me is so important, because people have finally said they actually see the reason to do it. Before it was always like, we just keep incrementally growing our environment. We're just strapping it on we're just putting more clay on it. And then sometimes you take the leg off and you put a new leg on. We swap some components out, but it's very much an incremental growth. But I think that was a human pattern much more than a workload pattern. And now that AI has said you can't do it that way, we're reteaching people to go back to first principles. And I think first principles of virtualization should be from the ground up. This should be able to be treated as a set of abstraction layers that are fully automatable.
I agree with you. This is the funny thing about people saying cloud native and the misnomer of cloud native requiring a cloud.
Yeah.
When I look at cloud native processes, it's infrastructure as code, it's API driven design, it's immutability, right? Those are core tenets of cloud native design, right? Something Kubernetes has done a really good job of getting people to expect, the whole GitOps movement, where you can declaratively state something and then expect an infrastructure to get built for you, matching that declaration. These are incredibly powerful concepts. You're right, that we people should be looking at more generally in how they manage their infrastructure. The challenge that you have on the back of that is, right, you do need a lot of underlying automation to make those things go, right? Immutability is fantastic. Immutability meaning I have an operating system image, or we'll talk about operating systems since we're talking about bare metal. I have an operating system image that's completely locked. If I'm going to change or update that, I'm going to change how I build the whole image. I'm going to produce a new image and I'm going to deploy that image. So I'm not configuring machines. If I need to make updates, I'm resetting the machine and putting a new image of it back into production. We've been helping customers do that pattern for a long time. It's incredibly productive. Our customers who move to what we would call a rack scale architecture, where they're, even going back to something people might think of as old school, like VMware. We have customers who, if they have to patch VMware, they don't patch. They build a new image and they reset their entire rack at a time, right, with the new image. That's an immutable build. They have a new way to build the rack. They design all their processes so that they can replace the whole unit of work and go. And they get that down into like a 20 or 30 minute operation, right? I call it a coffee break reset. They'll use the term repaving. So they rebuild the whole rack and they go. That is a cloud native practice. It's just being applied to bare metal. And the more you line up your workload and your platform capabilities around that, right? That's what Kubernetes expects. The fact that we can deliver it on the back end, that's the key to making all these systems work together much more effectively. So you can say, all right, I need to reset a cluster, and then you're not patching machines on the cluster. You're treating it as if you were destroying a whole bunch of VMs and rebuilding them back into scratch. The difference is you don't get to sort of shift from one set of VMs to a new set of VMs. You got to reset the gear and put it back in place. But the effectiveness of using the cloud native approach in this is transformative.
Well, it's funny because I feel like I was such an early adopter of, like, I just hated the idea of having to incrementally know where every piece of infrastructure was. And so I would always sort of plan to like keep rolling my hosts around. I would move them in and out of clusters. And I probably was on the verge of getting, I could have got fired a lot of times for things like right click, remediate cluster. At like 4 o'clock in the afternoon, I would just remediate. I would patch entire VMware clusters, and they just keep rolling. The workloads move around. The SQL ones, you got to be careful because we never really did solve that problem. But at most workloads could easily withstand that. And it forced my team, because I would tell the team, on Thursday, I'm going to patch everything in the daytime. And if it's not ready, the company goes down. And it forced my team to think I need to be prepared for how do we monitor, how do we know, like all of this stuff. But it was, as I got into doing, working with Turbo and doing the tech evangelism side of the world and now seeing way more customer environments, I was like, oh, wow, so many people aren't there. I thought I was behind, and I didn't realize that this was actually a bit of an anti-pattern to how most enterprise infrastructure had been run at that time.
Yeah, it's stunning to me to see the number of people who, are, and some of this is just their incentives, some of it's their behavior, but they still, they'll still sit there. And we had two customers talking to each other, and one of them's doing rack scale design, and the other one is still looking at machine by machine designs.
Yeah.
And they were saying, but I can't do that because I have a service window, and if I have to take a machine out and I only have 30 minutes to recondition a machine and put it back into service, and I can't break those SLAs. And the person who's doing rack scale architecture is like, you don't do this work off hours. You just do it as it's built into how you run the process. And we roll every machine every month, and it's going to get all the patches. And I don't think about it. It just happens because we have all these processes that do it. And the other person's like, whoa, wait, no, I'd never trust the automation to do that. And they're literally holding themselves back from moving forward because they're holding on too tightly to the control, or they can't think of it the other way. Kubernetes has done a great job of helping people pull forward into that. And I do think, going back to this idea of the Kubernetes teams trying to push the OpenShift virtualization and the KubeVirt down, one of the piece of resistance they're meeting is, this like, well, you don't understand. You have to do all this with GitOps, and you have to do, there's a whole bunch of you have to do's that aren't actually you have to do's, but they're very proven processes that we know work for app dev. They can be applied to bare metal infrastructure because we do it and help customers do it all the time. But the teams have to be shown how to do it. They have to be given the permission to learn how to do it. And then they'll get to the point of, well, I wouldn't imagine it any other way. But they have to cross that chasm.
Yeah, there is an interesting incentive pattern that needs to be baked in, and that is probably what causes it, right? Is that we've literally incented behaviors of uptime, and I'm an older fella, so I've been around back in the days. We'd have like hero shots of your Novell screen, like 1,348 days up. But we had NLMs, so you could patch live. That's what people didn't see, was like, I'm not proud of the uptime that I haven't touched this machine. I'm proud of the uptime because I haven't had to touch this machine. I haven't had to take the machine offline. The operating system allowed me to be compliance, like all of that stuff was being satisfied with it. Then we brought in VMware, and people thought, hey, I'm going to do the same thing. You're like, whoa. That doesn't have NLMs. You don't have loadable modules the same way. So when you patch, it's disruptive. And now we took the old, I love 1,348 days of uptime, in a new infrastructure that has disruptive downtime. And now we created our own enemy. That, like, we said, okay, we have to be more careful. So only patch when it's safe, only patch off hours. And it was like, I think we walked ourselves into a bad pattern, and now we're being forced to rethink that, and it's finally accessible.
Well, this is one of the things that's funny about KubeCon, right? And I've seen this. There was a KubeCon I went to, the one in Detroit, where operators were starting to show up. But in the last KubeCons I've had, sort of like operators aren't quite as welcome. We had the same problem with OpenStack, actually, where we wanted open operators to show up and come in, and we kept talking developer to them, or saying, hey, you know what, you get over the system uptime requirements, or get over the way we patch it, or we're going to be constantly churning stuff for you and rolling clusters and things like that. I think it's a challenge in these communities that are very focused on promoting new ideas to find that bridge back and forth back into it. And it is a challenge for, you're at KubeCon. I don't expect people to, sort of talk backwards from their perspective into the operator groups. But at the same time, I do feel like people who are trying to come into the community from the operator's perspective can feel really lost for that, because they aren't finding people who are, and I was, I don't know if you remember in my history, right? I chaired the ops, SIG ops for a long time before it became cluster admin and kube admin and stuff like that, where they sort of moved away from the idea that I needed bare metal operations and networking. That we were taught, the conversations I was trying to have just weren't happening in those communities. And I recognized that I wasn't going to find people to do that. There are still plenty of people who run bare metal Kubernetes, but they operate it differently. Right. What they need is different. And that's okay. We need to not shoehorn, we've done a lot of work, is more than we have time for today, about trying to make cluster API or metal cube work for bare metal, right? Where the missing pieces are, and it's back to the heterogeneity is normal and useful from that perspective. And I think that's one of the challenges that we get into when we're in an open source community. It's really beneficial when things are very consistent and the same. That's where sort of the progress happens when you come back and you have more heterogeneous needs, or you have to figure out how to make a Dell XYZ work with this operating system in this network topology.
Yeah.
It's much, that's not an open source concern. That's an individualized concern. Granted, all those things are completely standard pieces, but the way you've put them together, make it very, the person who's maintaining something isn't going to want to come troubleshoot your networking topology. They'll just tell you it's DNS and move on, right?
Well, and interestingly enough, the fact that we have like operators in Kubernetes,
Goodness, yeah.
and it was like, in effect, that was like we were debasing the operations role of like managing resources and deployments to a CRD or like a piece of YAML, and like I'm the operator. Why are you making me YAML? It's like, but to that consumer, the buyer of that service is the developer, and they don't see below that. So the operator to them is, how do I get my service up? They don't care further down below, and they shouldn't have to. And I do like the idea that I want them to be consuming services, but for me to deliver that, I have to operate as a service provider, which can't be done if I'm doing artisanal, handcrafted build documents that require someone to have had familiarity with it. It's
in
risky.
some cases where it's okay to say these patterns don't match.
Right.
A lot of the patterns that we're talking about are ones where the goal is to have a very generic pattern, a cloud VM pattern, and to apply that to a bare metal machine that, even if it's in a pool and can be treated sort of generically, is still a unique entity that has very specific properties and needs, and we work very hard, right? We have a pooling API, and we can treat bare metal like a pool, and let you check machines in or check machines out. But at the end of the day, you're still getting a machine that is a unique entity with a unique network topology attached to a switch in a specific way, with storage with specific wear patterns and this amount of RAM, right? And there's no amount of wishing that's going to make that artifact generic.
Right.
Right. It's VMs are beautiful, right? You can make VMs that are completely identical and functionally the same. But when you get a piece of gear, if it has a different RAID card in it than the one next to it, it's going to need different drivers.
Well,
period.
In effect, like this is why everybody's talking. I didn't do a search on how many people said MCP. There's probably 400 mentions of MCP in the schedule, because if you do you even MCP, bro? Like at this point, there's got to be MCP is the hot new thing. But I like the concept of that. Like, I should be able to programmatically represent the capabilities so that something can consume these services. And in effect, I kind of see that, like, what you're able to do is you can represent the infrastructure as a set of hardware capabilities, and then you can configure it as such. And so that really feels like the right abstraction that needs to be there, especially now that we're, going to be super AI focused.
One of my favorite API design stories is abstractions are useful until they're not.
Right. Yeah.
And so, in any time you're designing an API, it's really helpful to have a high level abstraction that is workable. And then Ruby is like this. For those people who remember programming in Ruby, Ruby has this beautiful object layer that you can, map into SQL without any thought or effort at all. And it doesn't go very deep. So it's not hard to get past Ruby's object definitions and into a place where you have to write SQL.
Yeah.
And some people look at that as bad. What I look at it as is beautiful. So what they said is, look, we're going to hit your 80% use case. You're going to be really happy, very productive. And then when you hit the edge of that use case, we're not going to make our abstraction all twisty and taffy and weird. We're going to let you pierce the abstraction and do the work that you need to do in the native language of the systems. And that line, which is really hard to figure out exactly where the line should be, but that line is sort of a beautiful part of an API. You want a really productive API that lets you do a lot of stuff very smoothly and without much effort. But when you need to actually cross the line and treat infrastructure as, bare metal is bare metal, that can't be hidden from you. You need access to do that right away. It's one of the challenges with how I've been watching us, in the Kubernetes community, build up these abstractions, and they end up with a layer cake of all these abstractions to get all this increasing complexity hidden. When I'm sort of like, you know what? Look, we just need one layer, and then we'll do the stuff we need to do, and let keep the abstractions simpler. It's much more productive than this cascading, a little bit of abstraction to more and more and more and more. That's very hard to sustain and scale.
And when we think of it's a performance hit, no matter how much you slice it. I would always tell you cannot add abstractions and increase performance. No matter how you slice it, there's some non-zero amount of latency that you're introducing in the way that, and oh God, you made me cry. I wish that infrastructure was like Ruby. I could just say like server.first, like the idea of like this true object-oriented management of infrastructure. Like I should treat it as addressable infrastructure. This is what we've dreamed of. And then people just said like, oh no, I'm going to move up the stack. I'm going to do this higher up. And you're like, brother, you're introducing performance hell that you don't even realize until you're now heavily.
You and I have lived through, many generations of people building cloud abstraction layers, and they don't work very well, because as soon as you can say, hey, give me a VM across any cloud you want, but as soon as you get like a layer or two deeper, it starts to matter what the VPC is and the differences between regions and the storage backing layers and the network topologies, and abstracting those out to any meaningful way really becomes incredibly challenging. And so, AWS, Google, and Microsoft have no desire to create a common layer. And it's counter to their competitive advantage. But even if they did, the way they did things is not parallel. It's not sufficiently abstractable. And I think this is one of the things. Kubernetes has been brilliant in having a core engine that does the work that it needs to do. The CRD pattern, which I think is really fascinating pattern, it is very much like a stored procedure pattern. And I've lived my life in stored procedures plenty to know that it's very hard to scale and maintain stored procedures in a generic way. And so the CRD pattern works to solve a lot of problems in a really interesting way, but cascading a whole bunch of CRDs together can be a really challenging way to maintain systems at scale. And it's one of the reasons we have all these, thousands of clusters pattern for Kubernetes, because the blast radius for a CRD, or the version of a CRD and the operators behind it, it's very hard to maintain a CRD for 10 different systems or across multiple versions of your own app. And so you end up needing a way to synchronize all of these components that you've built together. And so, we have a very logical cluster boundary for doing that, and CRDs within the cluster make tons of sense. But having CRDs that are cross-cluster or generic across your whole organization, I haven't seen that pattern as much. It's one of those places where it's very hard to write a generic stored procedure. It's very hard to write a generic CRD that then implements different backends and things like that. It's not saying the CRDs aren't incredibly valuable. The community has really done amazing things with them. I think we just have to be realistic about how generic they can be.
Yeah, when all you have is a Kubernetes hammer, everything's a CRD. Everybody just started to say like, let's do CRDs for all, and it was like, whoa. It's cute, but be careful. Even on the cloud application side, we saw as people said, like, let's move to using serverless. We liked the idea, like it was a beautiful abstraction layer. It gave us the right capability to call it on demand. But like, well, then how do you manage them? How do you do version control? How do you keep track of it? Like, how do you do drift management? How do you deal? There's so many things that we didn't think about that now became very artisanal, localized, developer team, centralized things. And we just immediately went to like move towards generics. And then let's make specialized generics. And
it's funny, if I go back 7 or 8 years when Lambda first surfaced and serverless first surfaced, people assumed that we would never again need containers or virtual machines. We just write everything in serverless, and it would be the only way we developed apps.
Mode 2, brother. Mode 2 is mode 1 and mode 2. We're going to mode
dear.
1's gone, right? We're on mode 7.8. N. Like
we're gonna have the same thing with these MCPs, right? It's MCPs as a translation layer are incredibly powerful. We've been doing some really interesting work, building prompts to make Digital Rebar easier to consume from a vibe coding perspective. It's one of my special projects, and preloading with some knowledge or helping express routine ways is incredibly powerful for this. I think we're going to see a lot of value for people consuming in generic ways. But just like you're describing, the repeatability of those patterns is really a question, right? Every time you ask an AI something, it's inventing a new answer for you. It's not really, unless you're very concrete and specific, it's not really learning from its own mistakes. This is what we learned, is that we had to help it learn. And when we would learn foundational knowledge, we would feed that into the prompt for the next time we went through the questions. And so context and building that data really, really do matter. Otherwise you're back to, one-off type of solutions.
And you certainly don't want, and so a lot of people are going to try this, like, hey, why don't I just vibe code my infrastructure automation? And like, do you think the same platform that, you're like, hey, I'm going to do this. And you say, perfect, we're going to put a square here. And you're like, no, I need a circle. You're absolutely right. Let's build a circle. Like, I appreciate the cheerleading of LLMs that they're like, you're absolutely right.
Thank you for pointing out that glaring error that I made. We have, especially when it comes to bare metal, we have a core concept called an infrastructure pipeline in Digital Rebar, where we chain together long sets of proven automation. And one of the things that we do as a principle is we don't build pipelines for each type of infrastructure. We have a pipeline, and then we keep making the pipeline more resilient and making it better to handle all of the things that come at it. So it's this very deterministic sequence of steps that has incredibly deep embedded knowledge, and it keeps improving from that perspective. The idea of vibe coding that, where you could say, well, hey, Rackn, I don't need all this long pipeline of stuff. It does things I don't care about. Why did you add LLDP into my pipeline? It's like, okay, look, I know you don't think you need LLDP, but you may in the future, So we walk through all these steps. The challenge with any of the vibe coding stuff, it's really powerful for a lot of business knowledge or a specific thing being tied into something else, like an orchestration use case. I think that's very interesting for that. But there comes a point when you're like, I need to tell you how to do this thing for me, and I need it to be reliable and fast. And you don't want an AI making it up or learning from its mistakes and repairing as it goes. So if you were going to do a bare metal automation, the vibe coding, it doesn't have a lot of history. There's not a lot of reference material that it can pick up. And even if it did, reading, HP's manual about how to configure the BIOS is, frankly, I can tell you those manuals aren't that useful, and they're often not correct. They're more wishful thinking in a lot of cases than actuality. And so you actually have to go through and build up, the system to very specific standards in a very specific sequence. And unless you do it exactly that way, then you're not going to get a repeatable result. And that's the thing that's missing here, right? When we look at building and running infrastructure, it really is about time to value, repeatability, right? How much I can take automation that I have working in one environment and forklift it into a new environment and have it just work.
Yeah.
That requires incredibly careful deterministic planning, infrastructure as code, repeatability, and the AI pieces don't think that way. They're designed to, I'm going to solve the problem you've laid out for me using the information I have. Doesn't worry about the next time you have to solve that problem. Doesn't learn from its mistakes with this. You have to guide it. Maybe it'll get smarter, but the more I see it, the more I see that there are high stakes deterministic things that AIs will build on top of. And then the human interface where it's like, hey, I need to find 6 machines that need this patch and are available under these conditions. And you write that in English and it translates that into the exact thing and then uses an MCP to do the queries and pulls back, hey, here's the 6 I have. And I think this one's the right choice for you because you like red servers and not blue servers. That's going to be incredibly productive from an operations perspective, built on top of good, clean API abstractions.
Well, and in a system that understands state, idempotent or idempotent, whatever, however I pronounce it every time, but like idempotent as a concept, I used to have I had heroic PowerShell scripts. I could spin up an entire disaster recovery environment from metal deploy, throw ESX on there, and then I would blow out a complete DR environment all with PowerShell. Really cool stuff that I built. But I would say this is great, and then someone would say, what happens if it goes wrong 3/4 of the way through? I'm like, wipe it, start again. There was you couldn't rerun the same script twice. Terrifying things would happen. And so the rigidity was built into, as automated as I could be, I was automating rigidity. Mm-hmm. And that's the risk of, if I'm going to vibe code my infrastructure automation, it doesn't care about, repeating this transaction and thinking of drift management. And it's just going to say, sure, that's a great idea. Let's rebuild the whole thing. You're like, whoa, hang on. Terraform was brutal for this with AWS infrastructure. Not that I'm going to rip on Terraform, but I'm going to do this fantastic. I had a whole educational build. Terraform blows out 30 lab workstations, does all these deployments, really, really cool stuff. And then I would go to make I just going to add one extra change in there. And it's let's redeploy all 30 of those machines into a brand new VPC. And you're like, whoa, hang easy there, Tiger. I just needed one extra nick on the host. But because it didn't understand how to deal with drift, it just had to rip and replace everything, which would be great if I wanted it to do that. But that was, now I'm a limitation. What I see from what you're doing is you're actually treating that as a feature of everything should be able to behave that way, even if you don't want to. And so I like that you've built the process to be very modular and stackable, understand drift, understand the relationship of drift to other elements, which nobody else is going to do in a bespoke provider. AWS doesn't care how Azure works. Azure doesn't care how Google works. VMware doesn't care how, CloudStack works. Or hardware or whatever. So the fact that you're approaching and you're becoming that Rosetta Stone to hardware so that I can express my demand, my need for infrastructure, and then you can deliver that in a repeatable, idempotent, compliant way that I can then, now I can think about repaving and wiping and all of these things, because life cycle goes beyond the first deploy.
This is, people really have to think this through, right? It's, you have to, especially we talk about AI workloads, but anything, right? The rate of patches, new versions, you throw new drivers in, NIC cards, we're getting increasingly high frequency of changes in all those pieces. If you don't have a comprehensive way to keep the systems up to date on an ongoing basis, you don't get, like you talked about earlier, you don't get to do your magic incantation, assume the server's right, and then roll with it. Terrifying. The idea that you might get a server shipped to you from a factory and install on a rack and then just put that into production. We have customers who would, oh my God, that would they'd have to report themselves to the government for security violations because they didn't have provenance on the BIOS that was installed on the machine. They literally have to rebuild racks and go from scratch, right? And it's always worth noting for people who don't know our whole history, we're a software company. So when we talk about doing this, it's actually the customer doing it. We just write the software, they run the software, it's air gap behind their environments and things like that. So that type of security concern is incredibly real. But then, as soon as there's a patch or an update, they're going back through and, testing it, making sure it works, doesn't break the layers above, and then re-rolling it back as fast as they possibly can and into the environment. For the AI workloads that we are part of managing, they are getting weekly updates on their Mellanox drivers, weekly updates on the GPU infrastructure. They're taking, they're testing and validating, any patch they have to improve the security of the system or the performance of the system. They're going to go through and make that work. Some of them are big enough to even write their own BIOS, to manage and improve performance, or just make sure that they have provenance from that perspective. And that's, those are pretty extreme cases, but what I've seen is that every customer that we have benefits the closer they get to that, immutable, fast rolling type of automation, and then build that into their underlying processes so that they're constantly, what I would say autonomically refreshing and updating and having processes where they can go through and test and do it. And your idea of resetting a whole system, I can't figure out what's going on with this. Your first instinct, is to capture logs, but at some point it's like, well, maybe we just need to re-roll the rack and set it up again and see if that jiggles something loose. That can. That's not a bad, the IT adage, have you rebooted the machine yet?
That's right. Have you rebooted the rack? Have you rebooted?
Have I re-imaged the rack and reinstalled everything to see if I can fix it? Is not a bad way to go. And then if something then happens as a second time, if it's continuing to happen, then you can start doing diagnostics and troubleshooting. You could re-image the rack with better diagnostics turned on. It's thinking of things at a different scale, which is part of where Kubernetes has gotten to. It's why it's different than a Slurm type of system.
What's funny is the very same enterprises that would have adopted a VCE because of its very printable template type of delivery that they didn't have to worry about, and they it was like all these sort of guarantees on the operation of it. And that's what's like, in a way, the promise of AWS Outposts, and it had really interesting ideas. But I think what happened was we realized there weren't as many people that needed that, and there was so much diverse infrastructure that you can't really stop doing that and move to this other like de facto bomb of like, here's my bill of materials. It's going to be like, you need to have a dynamic bill of materials based on the workload, and then I need to have control over the capabilities of automating and connecting those bits. I can't depend on VCE being ready on call. I'm like, oh crap, I got to do a batch this weekend, I need help.
You're hitting something that for us has been a real interesting dilemma in market. Because you're saying VCE, I'm thinking VxRail, which is Dell's version of the embedded infrastructure. Incredibly expensive stuff. Their day two was still sending people on site to run patches and things like that. They really didn't, because it's hard. It's really hard to do. But they sold you a prescriptive BOM to install prescriptive software, and still had challenges on what the patch and update was. And then people buying that gear, it's not repurposable, even though it's generic gear. And this isn't specific to Dell. It's, all of the VMware appliance solutions have this sort of overarching approach to it. And, one of the things that we see is very problematic there is the force fit. Right. So part of our mantra is heterogeneity is welcome. And so the idea of forcing people to buy one type of hardware to solve the problem for our convenience is actually counter to what we actually see is helping companies save money and own their operations, right? The idea that I can intermix, and our customers do this, different vendors' gear, so that they can, avoid being hostage to, a Cisco or a Dell or an HP or a Lenovo or Supermicro saying, yeah, you have to buy this gear. And, oh, by the way, we stopped shipping that model, so you have to get this new model, which is not exactly the same. And so all your automation is going to break. Right. What we really see as a benefit is, you want to be able to have control of your destiny. If you're going to run your own infrastructure, right? And that's our customers are the ones who are like, oh, wait a second, I can save a lot of money running my own infrastructure. I want data sovereignty or control, so I'm gonna run my own infrastructure. If you're going to do that, being able to have a heterogeneous footprint and mix and match operating systems and hardware providers and network topologies, that's essential, right? We've seen that even on the biggest, right? Facebook and OpenAI, are now starting to be like, wait a second, we don't want to be only NVIDIA. We don't want to be only InfiniBand. We want to have Ethernet. We want to have AMD chips. We want to have a healthy ecosystem for our clusters. That is not, if that is core value to people who are running their own infrastructure. Our goal is to make it so that it's much easier to run your own infrastructure, and you don't have to be these giant companies, looking at, thousands of racks of gear to make a decision that, owning your own infrastructure is valuable and important. And so to do that, it's this abstraction layer really carries a tremendous amount of water for getting you to that point where you're like, okay, I can buy a rack of gear and automate a rack of gear and keep it running without having to have the same level of technical acumen that I would have had to, even 5 years ago.
And it also, with an increase in what we're seeing with CXL adoption, whether it necessarily gets to the enterprise, because everything needs it. As a concept, this idea of a true network composable infrastructure, for us to get there, we have to have processes that can deal with composable infrastructure. And this is what always gets me. Like, people want the dream. They're like, I want to have complete freedom. You're like, perfect. You have to do X, Y, and Z. And they're like, oh, I can't do those things. You're like, well, you're never going to get there. And then you say, well, why can't you do those things? Well, because it's a burden on my team. It's a burden on and it's never really a compliance problem. It's almost always, this is a new burden on my team.
Yeah.
And they're already overloaded. And so they see that as the barrier. My team can't solve the automation problem, so therefore we can't be automated. It's like, oh,
This is a truism in IT as a challenge, is that IT is usually not able to sharpen the saw to improve, right? They don't have a lot of time to pull their head up. This is a classic. One of the things about Google SRE that gets forgotten is SREs that are 100% busy are not actually SREs, because part of the goal of an SRE is that you're constantly putting time into improving the processes to reduce your toil.
Yeah.
And you can't do that if you don't have time to do the work around it. And one of the things that we see that's barriers to adoption is people say, oh, I love what you do. I love the architecture and the approach of how you do infrastructure, but I don't have time to stop what I'm doing to, implement improvements in how I manage infrastructure. And you're like, well, why not? You're like, well, I'm too busy managing my infrastructure.
I'm too busy doing the thing I'm trying to automate.
And so, it is really a challenge of how people look at that. We see, when we look at OpenShift virtualization as a potential market, we have a lot of customers who are very excited about OpenShift virtualization as a replacement for VMware. But the learning curve, which shouldn't be that high, they have a tendency to, instead of showing up and asking for help and saying, all right, I want to see how the right way to do this. And we've been doing a lot of work to give people a very consistent, repeatable base starting point for this, so that they don't have to go through learning Kubernetes and learning, or if they know Kubernetes, learning infrastructure, if they know infrastructure, learning Kubernetes. we've really put those things together so that there's repeatable patterns that people can start with and then learn what they need to learn. Otherwise, the barrier when you don't have a lot of time is incredibly high, right? If you're a Kubernetes person, learning infrastructure is very hard.
Right.
It's totally different. If you're an infrastructure person learning Kubernetes, it's compared to VMware, there's not a lot of click ops, there's not a lot of UX. It can be very daunting. And so, you really need to come up to a base level and not try to learn it yourself. We see this with the AI builders, especially. They're out there, log SSHing in and learning Ansible and trying to figure out how to patch stuff. And it's taking them months to bring clusters online when, there really is nothing unique in the infrastructure of a cluster. It's complex, but it's not different.
Yeah.
If you'll accept my difference between complexity and difference, something can be very complex because it has a lot of parts that are configured in unique ways, even though the configuration and parts are completely standard parts and understandable configurations. So that's one of the things that we see people falling in the trap of a lot. The complexity is overwhelming, even though the difference of their infrastructure is very small, and they could get more help than they get.
Yeah. Well, and we've also, we have this sense of belief that somebody else must have something different. Like the people that are at the hyperscalers, they must have some fantastic, amazing tool that no one in the world is ever allowed to get. And you almost want to tell me, like, that's us, right? Like I'm telling you about a thing that you're going to use that your provider also uses. Like it is tough to sort of rain on their parade about that there's this magical thing they'll never have access to.
This is funny. In a lot of cases, right, the tooling that we built is because our goal is multi-customer and repeatability. The architecture and the tooling that we've been able to build is more generic, more useful than something that a hyperscaler built to be specific. Although we do have hyperscaler customers who are like, wait, I need to automate this. It's different than my custom bespoke stuff, and we help them provide the APIs that they need on commodity infrastructure. It's what our specialty is. But the thing that the difference in a lot of cases between those companies and everybody else is actually not the tech. We help with the tech and we can normalize that field. It's actually discipline and process.
Right.
And the thing that we found over and over again is when we bring, because at this point, Digital Rebar has so much embedded knowledge from a process perspective and implementing best practices over and over and again as code, right? That's infrastructure as code. It's actually process knowledge that's baked into the product. We show up and can really help people move into a much more disciplined, process-controlled manner of operations. And we've worked hard to make it easier to follow good process than not follow good process. Yeah. And that's been an amazing thing to watch how quickly somebody can improve their operational capabilities by leveraging the built-in processes and following our best practices. They have to give up the ways they've been doing it and move into that. Sometimes there's resistance for, wait a minute, what do you mean I have to have an immutable automation set? I can't just, hand tweak whatever I want whenever I want. It's like, well, you can do that, but let me show you the easier way to upload that automation and test it. That's a tremendous difference in the thinking, and people really shouldn't get discouraged. That's the biggest difference is really process and controls for hyperscalers. It's not magical tooling and infrastructure.
As we know, when we put a human in the loop, goodbye US East 1 for 11 hours.
This is I think that people think that Amazon has some super competitive advantage on buying cheaper gear or manufacturing their own gear, and they do get advantages. I don't want to, but at the end of the day, you can buy a Dell server very cost effectively, or super micro server, or now, Quanta, you're going to get more quality variations, when you go for a cheaper server. But, you can buy servers very cost effectively and get a great ROI from the hardware and the commodities. They are not, their advantage is not price of the gear.
Well, and I'd say I'll use, not that coffee's always on my mind, but coffee as an example, that like Starbucks is seeing a market pullback, not because people necessarily are changing their consumption patterns for coffee, but what's been made available is low cost, high quality espresso machines. So some of those capabilities now are closer to home, and you don't need to go to Starbucks to get the same coffee every day. Oh, well, what do you know? What if we were to take this analogy and suddenly map onto, what if I could have the cloud capabilities, and now I can actually affect down to the metal.
Yeah.
And this is what is now a consumer available, or prosumer is really what it is. Like the average SMB, if I'm an SMB and I want to stand up Kubernetes, then good luck. Here's EKS. Fantastic. Don't ever call me. They don't need to solve this problem. I would say this, I'll quote Eric Peterson from Cloud Zero. I love his thing. He says, every engineering decision is a cost decision. And I think for me, if I'm an infrastructure team lead, a platform ops team lead, I want everything that my team is doing to be revenue generating. Why wouldn't I treat that the same way as any other engineering decision? So if the cost to me is that I'm getting smarter people that are going away, and I keep having to rehire new people and teach them these crazy artisanal builds that we did, it's counter to my MBO, my OKRs as a platform lead should be almost like a board level demand that I can react to rapid changes in market. I can react to ransomware. I can react to having to suddenly repatriate cloud workloads. I can react to, we suddenly have access to some H100s. I don't know how we got them, but a guy in a van showed up and I've got a bunch of H100s and H200s that are suddenly on the dock. Well, I need to so rapidly be able to consume that and turn it into business value. Yeah. It's not going to be done by having my team go out and vibe code infrastructure automation.
I know that's not where your team should be adding value in the mix. And I think people, have historically, confused, historical data center and IT with, cloud from a access perspective, right? Our best customers are good cloud users. The best, we get excited when somebody wants to use bare metal in a cloud-like way. That's a green light for us. If somebody's, thinking back to the way, you managed infrastructure, 10 years ago, where each machine was bespoke and you had to, hand tool them, and you spend a lot of time patching, and it takes you weeks to execute a project because the bare metal is very, lovingly set up. That isn't really a good, strong use case, right? We help customers get to a factory model. It transforms how quickly they deliver projects, right? This is one of the things, that you get people used to. You don't have to have a pool of gear that's just waiting around for you. But, the way we help people build infrastructure, they can move a project through much, much faster. We have some great case studies of, companies doing, tens of thousands of machines of migration and rebuild in months, start to finish, because they've automated all the steps that go into it. And so when they get to the time of like, I just have to, build on top of my foundational piece. There's the reason we call it Digital Rebar. It's a homage to the idea of, stronger foundations. Yeah. And the extent to which you've built that abstraction layer up, it creates much more forward speed and momentum, just like you had with cloud, right? Cloud, the benefit of cloud, and we're a huge fan of cloud. We use it all the time, of being able to prototype, move through, get infrastructure, and keep going. That pace and cycle is absolutely critical to modern app dev work, right? The idea that's going to hit a brick wall when you switch to physical infrastructure is an outmoded concept. You should be able to just continue all the way through. We use cloud because we continue our development process all the way through, and the abstraction layer is such that if you're testing and building something that works on cloud, we're confident it's going to work on bare metal. And so you don't have the shifting gear, downshifting because you're now on physical infrastructure. It's all one type of infrastructure with the same controls, the same immutability, the same pipelines. It's that's an accelerative effect. But you're right. People looking at it differently is part of the challenge with that.
The idea of the factory, and I guess this is what always happens. We use words to describe a lot of stuff we do. We talk about toil and technical debt, and we use these really negative, sounding things, and we do it on purpose because we're trying to evoke a reaction or an emotion to that. Like, so this is a bad thing and we want to do less of the bad thing. So what is the good thing and what is more of the good thing? And this idea that we should treat, Randy Bias, I always love this, I'll forever quote him on this one. He says, the cloud is cheaper as long as you're willing to pay more, and but the advantage to cloud was that I wanted to rapidly prototype, get my thing out there, and then once it reaches an operating model where I understand the economics are now swinging, I need to be able to rerun that prototype in another place. I'm going to now move to sovereign infrastructure, but I can't because I don't have the underlying processes that allowed me to prototype rapidly. But what if we could? And that's the magic of what you're delivering to me, is that it's democratizing cloud access without treating it as being cheap. It's not commodity in that it's less valuable. It's commodity in that it's rapidly replaceable, because the value of a factory is not how good the factory is. The value of the factory is how much product it puts out.
That's right. Well, and the word commodity here is really about interchangeable parts, right? Something's a commodity when it's interchangeable, when you can get it from multiple vendors, when it's more interchangeable, right? And you're entirely right. The core to what we try to do is commoditize the data center operations so that you can have standard processes that apply for our customers all across their fleets. That's incredibly valuable, right? Most people with multiple data center locations or multiple physical stores, edge, what people would call edge, they have a lot of variation and heterogeneity. Once again, heterogeneity is normal between their locations, but that means that their processes are different or hard to manage or require manual intervention. So the commoditization here is the idea that I can have 10 data centers with different vendors of gear and maybe different networking topologies and different sovereign needs, and still treat them as close as the same as I can, right? That's the commoditization. It's not just a price thing. It's actually a repeatability. It's interchangeable parts. Yeah. Those are things that make infrastructure a commodity from that perspective. It's one of Amazon's power, right? Of they built data centers all over the world, and you can interface to all of them by just changing. It's not entirely true because the APIs do vary and the services vary. Heterogeneity is normal. But you can just change it from US East 1, which hopefully people do, to a different data center, and pretty much everything you've done, because they've commodified the cloud for their own users, is consistent and repeatable. That's right. That bringing that back into a physical data center is that's what we've been working a lot of time to do, and the results are incredibly powerful.
commoditization. As I always say, I like artisanal coffee and commoditized infrastructure. And
well, your artisanal coffee is becoming a commodity, right? If people have their own ability to grind their own beans and brew their own coffee, then you've commoditized the process.
yeah.
Right. Beans are definitely a commodity, but the demand for beans is low if there's not a commoditized process to back it up. And I think that's a really interesting analogy here to think through, right? You have a machine, but it really is the process that you've made much more standardized and repeatable, and so everybody can do it. That's the important thing.
That is the money. And, boy, as always happens, I always think like, we'll have a quick chat. And I'm like, boy, I got 8 hours to go. I could keep going.
This is at least two different podcasts combined into one. Yeah. Somewhere there's a KubeCon discussion too.
Yeah. So we'll obviously we'll be at KubeCon. So maybe for folks that are catching this prior to, what's your plan for KubeCon, Rob? Like, I know you're going to be there.
Definitely.
So what's the way if folks want to get connected and hit you up while they're on site, or even be on the event and wherever else?
I'm on all of the socials. I even scarily enough reactivated my X account. I am Zehicle consistently across all of those socials. Although probably the simplest is to find me by email. So I'm rob at rackn.com. I'm happy for you to get in touch with me that way, or through LinkedIn, or any one of the numerous channels. I am mainly in the hallway track for KubeCon, meaning I'm walking around and talking to people. That's my goal. We're not exhibiting as a booth from that. And then we will be at the OpenShift Commons the day before.
Fantastic.
So if you want the small experience, that's a free Red Hat event where they're going to be talking about OpenShift. We are doing quite a bit with OpenShift, and so we're excited to be at the Commons. We're not sponsoring. We're sort of peripheral, as bare metal often is, to a lot of these discussions, but very much a part of it.
Well, the beauty part is if you find Rob, you'll find me, because I'll be at OpenShift Commons all day, and we'll be at KubeCon. I got a lot of good stuff. So yeah, for people that are at KubeCon, definitely come and find either of us. It's going to be a blast. I'm looking forward to it. I've got some podcasts and panel recordings, so you'll be featured on a panel as I'm just getting that organized, and this is such a great opportunity. So thanks. I love that I feel like we can do the thing that we've been talking about for 10 years now. And it's like every band that spends 10 years playing a lot of small bars to get that eventual, contract. You have become an overnight success 10 years into the market, where, people are Rackn ready. And I think we have finally caught up to where you have been since the start. And it feels good as an outsider looking in, because as a friend, I've watched you battle industry demons in like educating the market on what's possible and moving people towards what it takes to get there as providers, as vendors, and like, how can we all work together to truly satisfy that customer need in a way that fits compliance, fits security, fits repeatability. And I just feel like we're finally ready for Rob. We are Rackn ready. This is it. And it's time.
I like that way of thinking about it. I can tell you, we have, through our journey, one of the things that is funny about infrastructure is, you can't do 99% or 95% of infrastructure. And so one of the things that we found over that 10-year journey is, we have at this point hit and fixed, most of those little gaps that keep platforms from, handling the reality on the ground. People have often, and I didn't realize this when we were starting our journey with Rackn, there's no such thing as development metal. you don't get to say, well, we implemented most of what you need and just work around the bits you missed, or, this is the beta version or the alpha version. Sorry, it's going to be a little buggy and your data center might go down 1 or 2 times because you hit a bug.
You may need to swap out drivers a couple of times, try some different
swap
ones.
Out drivers. That's in the backlog. We'll get to it. And there's definitely stuff that we build and we continue to build, but from day one, the demands of running bare metal are such that systems have to work. You're putting things in production. You need somebody to call if something's not working. You need a way to fix it. You have to, when the BIOS, when and this happens to us every week, when one of the OEMs patches their BIOS tool and adds a flag that changes the behavior of the tool overnight, and customers go and roll it out. You have to be able to absorb that, respond, and fix it. And that's part of what we've built now is we've just been through so many of those scenarios that we've covered so much of the universe that when people show up and ask, hey, can you handle this, can you handle that, we've been handling it, and nobody wants the I think we can maybe. It's you're running production gear. It's got to work. You don't have time. Nobody has time, especially if you're buying, $250,000 servers with, 10 GPUs in it and a whole bunch of fiber channel. That system's got to be up and running yesterday.
Yeah.
And, if you're okay with it taking weeks or months to bring up, then I would love to see your bank account, because I certainly couldn't afford to take that much time. And so that's the type of scenarios we're dealing with now. And you're right. I think you're right. The market has caught up to that for an extent. And the price of gear is actually, for AI has gotten to a point where people notice if you can't get it running.
And it's, to me, if it isn't already for many of the folks that you're talking to, especially sort of in that, like the F2000, F200, as we move up to like the global 200, these are board level requirement. These are like, this is the type of stuff that actually makes it up to, how they operate a JPMC and, a Barclays. People get surprised by that sometimes, but it's like, a CIO isn't just career is over. Like, oh, we'll let them know how the board meeting went. It's like, no. They're like that. The platform, operations is moving up to somebody that's going to be sitting in that boardroom and having to defend business needs that we can achieve in the next quarter, because they know that they've operationally got something that they can deliver it on.
Yeah, it's stunning to me, the fact that more boards aren't just pounding the table, asking, wait, you bought, $1 million, $10 million, $100 million for the gear, and it took you how many months to get it operational so I can get an ROI on that gear? I mean, it's, people should care about that type of delay. And with AI, they actually care about the opportunity cost too. It's not just the gear that you bought, it's the AI workloads that you haven't been able to start. Or the virtualization renewal that you're about to have to pay and lock in another year or 2-year contract, because your OpenShift pilot went off the rails because you had a developer telling you how to build infrastructure and you didn't get any closer to a deployment. Right? These are very real, and I agree with you. They're C-suite level imperatives that people should own. We watch this happen even with our customers, and still allow pilots or proof of concepts to go very slowly because they aren't thinking about how to do production during the pilot or the proof of concept. Otherwise, if you don't do it if you don't think of that from the start of the process, you're in deep trouble. We're making this outro really, really a whole other podcast. So
exactly. Podcast part 2. We will stop. But there will be many more great conversations like this and lots of stuff coming up. So folks, definitely do check out rackn.com. Because if you aren't rack in, you are rack out. Like, let's do this. Everybody's got to be thinking this way. it's I love how accessible it's become, and also the amount of great content that you put out. So thank you for putting a ton
Thank
of
you.
great content in the world, and the videos that you share, the amount of podcasts that I hear people all the time saying like they've been educated by this. They know your voice, not just as your actual voice, but as a voice in the industry that's kept that searchlight on when other people stopped looking, and now we've found what we
I,
came for.
I appreciate that. We work really hard to really put out some unique educational material that we don't, if we can't find it on out there on the internet, we're gonna talk about it, and we'll put it out there. So I appreciate the nod. The Cloud 2030 podcast is where we talk about either both advanced tech ops work targeted at operators, very unique content, or we have a strategy session where we decompose what's going on from a tech and geo, in a geo frame, in ways I haven't heard anybody else discuss at all. It's really fun. So I appreciate the nod for that. It's been a labor of love.
Nice. I feel like we should end this as a streamer. That's what we need. We need those like streamers, like, and the name is DiscoPosse. Like the name is Zehicle. Like that. You gotta have one of those closers. But there you go. We are Zehicle. We are DiscoPosse, and super proud to see what Rackn is doing. And we'll see all of you at KubeCon.